here we have a polynomial. We want to write it down in factored form, and then they tell us what looks like 2 zeros. And this is what, when they say multiplicity 2, means this 0 is repeated twice. Why is that important? If I know this is a 0, then I know that x plus 1 is a factor, because that's what I could put in there to make that 0. Multiplicity 2 just tells me that that's a factor twice. Why is that useful? Well, I can take this whole thing now, and I can divide by this, and then I can divide by this. And so I'll go from something that's degree 4, I'll divide out a factor, it'll be degree 3, I'll divide out another factor, it'll be degree 2. And degree 2 we can deal with, right? Because that's quadratic, so we can use quadratic formula, or maybe it'll factor if we're lucky. So if I'm dividing by this, I'm putting the 0 that goes along with it in the box, and then I'm writing down these coefficients. And this is where we like synthetic division, because it does this very quickly. Alright, so add multiply. So add multiply by -1, add multiply by -1, add multiply by -1, add multiply by -1, and add. So I get a remainder of 0, which tells me, hey, that was a 0. I kind of knew that from the beginning because they told us, but it's nice to see that it worked out. Alright, so now what can I do? Well, I just took this from this x to the 4th to 1x to the 3rd minus 3x squared plus 25x plus 29. So now that I've divided something out, don't go back to the beginning. Start from there, and we're going to divide another factor out. In this case, the other factor happens to also be x plus 1. So we'll put -1 in the box again. And so we're going to have 2 factors divided out. So add multiply by -1, add multiply by -1, add multiply by -1. And it looks like that divided in evenly also. So why is that useful? Because now that I've divided out 2 factors, this went from to the 4th, this was to the 3rd, and this is now 1x squared minus 4x. Right, synthetic division is just telling me what coefficients are in front of those. So I know that what's left after dividing these both out is 1x squared minus 4x plus 29. So now that I'm down to something quadratic, it's easier to deal with. So it doesn't look like that factor, so I'm going to have to use quadratic formula. So negative b, so negative, -4, the negative will cancel. And then this will be -4 squared, which is 16, minus 4, a is 1, and c is 29. And then all over 2 times a. So this looks like 16 minus 116. So we end up with 4 plus or minus the square root of -100 all over 2. So what can I do to deal with negative square roots? Well, that's where my imaginary or complex numbers come from. So I can take the square root of 100 if I pull out the I first, saying I is square root of -1. And then these are both divisible by 2, so 2 plus or minus 5i. So notice we knew there were going to be 2 more zeros here, so we just found the other 2 zeros. Alright, if I know that these 2 are zeros, why is that useful when it comes to my factors? Because factors are just x minus whatever your 0 is. So be careful in the complex ones or the ones with square roots about parentheses, because it's got to be x minus the whole number. So whatever your 0 turns out to be, you know that x minus that number is a factor. And then also to save space if you want to, you can write this as x plus 1 squared, because you have 2 x plus 1s there. So we have 2 plus 5i and 2 minus 5i. And so now we just took this, that was degree 4, and we have 1, 2, 3, 4 different factors. So we completely factored it.